Hi students, Dr. Vic here to talk to you again about econometric problems, and actually we're going to talk about the mother of all econometric problems perhaps is the problem of endogeneity. So endogeneity, the solution or a solution to it is generally using the method of instrumental variables. So we're going to be looking at our cigarette data again, looking at demand curves because we're interested in what's the price elasticity of demand for cigarettes if we want to implement a tax. So this is problematic. So you can have three reasons for endogeneity. The first is simultaneous causation. So here, as I mentioned on the website, price has an effect on quantities, but quantity being demanded or supplied has an effect on price. So both variables are in fact endogenous variables. Whereas in the past we've been treating quantity as the dependent variable and price as the exogenous independent variable. But theoretically, we know that there's some simultaneity going on there, so or an endogenous variable problem. So we need to correct for that, because if we don't, our regression estimates could be biased, and as we get more data, they would change over time, which is not what we want. So other problems with endogeneity, it could happen because you have omitted variables or you have errors in your measurement. So these are threats to internal validity. So what we want to do is we want to find an instrument that can predict price but is unrelated to quantity. In other words, an instrument that goes on the right-hand side of our equation and predicts that endogenous independent variable. But it shouldn't be related to the endogenous dependent variable, the left-hand side variable. So we need two things to happen. We need an instrument for price in this equation. We need something that affects price, but should not have an effect on quantity. It should not be part of our market mechanism. And so what we're going to do here is use average cigarette taxes. That's part of our data set. We're going to use cigarette taxes as our instrument because cigarette taxes are going to drive price. Prices are going to be really affected by those. It should be independent, or it perhaps is independent of prices and quantities, although the problem with any of these exercises in endogeneity is finding a good instrument, and it's very, very hard to do. And some part of the art of econometrics is finding those and arguing that they're good instruments. So let's go to Stata here. Again, I've brought in the cigarette CSV file. I'm using some of my same do code, Stata code, but this is a different do file. I bring it in, I create my variables, much like what you've done before. We're using logarithms, log transformations, and what I'm doing here is I'm implementing some tax. So we have a excise tax on cigarettes. Okay, we have a average cigarette tax per year, and then we also have sales tax. So we're going to fiddle with some of these tax variables as being hopefully good instruments for price. So we go down here. Let's first, so instrumental variables is essentially a two-stage process where the first stage tries to predict price based on our instruments. The second stage uses price to be the regressor, to be the explanatory variables for quantity. So two regressions are essentially going on. Fortunately for us in Stata, it does both of these things at the same time with IV regress. IV regress two-stage least squares. So it essentially performs two regressions for us. Okay, but first let's see how the cigarette tax does in predicting the total price of cigarettes. So PT is the price of cigarettes plus the tax. And we're going to do this just for 1 year to start off. And what we see is it has a significant, the higher taxes go, it has a positive coefficient on cigarette prices. There's an adjusted R squared of 36%, so it's doing an all right job. So we're going to try that first. So what we're going to do is, instead of regressing quantity on the sales price, Q on PT, we're going to, instead doing a regression, we're going to do IV regress two-stage least square. And our first stage goes in the parentheses here. The first stage is our endogenous independent variable regressed on our instrument, the tax on cigarettes. And then the second stage is going to take the predictors of PT, LNPT, and that's going to go in the second stage regression of quantities on those predicted prices. Okay, and over here I have a robust standard error option put on. So let's see what this does. This is IV regress. IV regress is the standard stata command for instrumental variables. Okay, so what it does, this is an instrumental variables regression using two-stage least squares. Has a higher R squared, 41, so that's, or high R squared, or decently high. And it says that it's just showing the second equation, the second regression equation, which is quantity on price. And this shows since it's using logs, we think of this as the price elasticity of demand, so minus 0.9. If you remember, this is not too far off what we had in previous videos. So this is the price elasticity demand estimated for two-stage least squares. And it says we have instrumented price using the tax of cigarettes. So I want to come back over here, and we should add income. We can do the same thing. We should be also controlling for income, but income is an exogenous variable. So income is exogenous to the model. Prices are endogenous, and we're instrumenting for prices. And so that addition does not really change our price elasticity of demand much. Now, what I'd like to do here is use an older command, ivreg2. And if you see at the top of this do file, you're going to need to install that yourself the first time you do it, or it won't work. But I like the ivreg2 command, so it has the same format, okay, as the previous command. But we're going to add this option called first. And what first does is that first, it gives us the first part of the regression, the first stage of the regression. Okay, and so it's done that already, I believe. Wait, where'd it go? Right here. So it's given us that first stage regression of cigarettes on prices. Okay, now what it also does is, I'm going on down, it gives us our overall regression. So again, this is the price elasticity of demand. If you look 0.9594, that should look similar to what we ran before, 0.9594. So both commands yield the same coefficient estimates. Now what I want to focus on are these two tests, the weak identification test and the J statistic. Now if we go to my website, I have put in an explainer of these. So our instrument has to do two things. The instrument has to be a good indicator, a strong instrument for our endogenous variable. So if it's not a good indicator, we call that weak identification. So the weak identification test tests the null hypothesis of that. And it spits out an F statistic. And if that F statistic is large, then we reject that hypothesis. We reject the null that they are weak, which is a good thing. So we're going to be looking for a large F statistic here. And if we go back Our weak identification test, we have a F statistic of about 21, and it is larger than these other these critical values. So that's an indication that we are we have a strong identification where we are we are rejecting the null hypothesis of weak identification. The second test is the Sargan-Hansen test, which is a test that not only does it have to be a good instrument, a good predictor of the endogenous, but it can't be related to our dependent variable. If it's related to our dependent variable in the same way prices were, then we're back in the same situation of still having endogeneity. So the Sargan-Hansen test tests that, is this uncorrelated with the error term? Is it uncorrelated with the dependent variable? And if our J statistic is sufficiently low, we fail to reject the null hypothesis of it being valid. And this is good. This is, hopefully this is what we want if we're looking for a good instrument. So here, our J statistic is 0. So it's very low, which is a good thing. So it's not exactly identified. So that's the first, that's why I like to use IV-Reg2, because it shows those test statistics. So what I want to do is go back and let's add a second instrument. You can have multiple instruments just like you can have multiple exogenous variables. So let's see how both cigarette taxes and sales tax, how they predict our overall price of cigarettes. And so before, I think we had an R squared of about 36. Now we have an R squared of 90. So what this is showing is that these instruments are probably going to be stronger. They're not going to be weak instruments, which we were kind of on the border before. We run this IV regress, and we get a higher price elasticity, 1.32 minus 1.32. I'm not going to go into, I'll let you analyze that a little bit. What I want to show you is these test statistics. So I'm going to use IV-Reg2 and go down to these test statistics again. And we go to, remember, weak identification, we are hopefully getting a very large number to reject the null of weak identification. And as you see, this F statistic is much larger, so indicating that what we have here, just as we suspected, is a stronger, the instruments do a better job of identifying the endogenous variable. And remember, our Hansen J statistic is, are we correlated with the error terms? And this is still sufficiently low. We do not reject the null hypothesis that we're doing good here. So that is that's our two statistics that we want to look at. That's using IV regress and then IV-Reg2. Now in your chicken project, you can play around with both of those. The paper gives you some ideas. It's much more complex set of equations that you're using there. But you, as I've shown you, you can add instruments, you can add additional independent variables, and it's not a problem. All right, good luck with everything, and I'll talk to you later.